section in chapter 6, or unit 6, is 6.4, confidence intervals for variance and standard deviation. Just to let you know, most of you probably already checked your Skyward, and the quiz yesterday was worth 33 points. Most people got A's and or did a very good job with it. If by chance you did low for it and want to do well on chapter 6 test, please learn from your mistakes, as well as pay attention to 6.4 so you can prepare for the chapter 6 test, which is next week. Now just kind of a recap of chapter 6. 6.1, 6.2 are based on point estimate for the mean. So we use X bar. The actual mean for population is mu. So we're finding a confidence interval for what the actual mean is. On 6.1, the sample size is greater than or equal to 30. 6.2, it's less than 30. 6.3, we're actually finding the actual population proportion based on the sample. And the critical, not the critical value, but the point estimate for that one is p hat. 6.4, what we're going to go over today, deals with variance, the actual variance, and the actual standard deviation. S squared stands for the sample variance. S stands for the sample standard deviation. Now there's times, Ms. Jack, you may need to stop this video for allow the students for some time to work on things. I've recorded this video twice already, and it did not save, so I'm having a lot of fun doing this. Not really. If you notice, sometimes the screen will not cooperate with me. I'm in Mr. Glandon's room, since my hour is being used for a different class at this time. Now, what I need you to get, or what I'd like you to get from this definition, is the critical value on 6.4, or critical values, is going to be what's called chi-square. It looks like chi-square. Critical values. Some things to know about it. A chi-square values are all greater than or equal to 0. And you'll notice the greater the sample size, the more it approaches the normal distribution. But the chi-square distributions are positively skewed. But what you really need to know is this. If you're given a chi-square, you have the right tail. Chi-square, you have the left tail. The chi-square, the right tail, is going to always be bigger than the left tail. So the right tail, which is bigger, and the left tail is smaller. The C stands for level of confidence. Like a lot of times we're dealing with 90, 95, and 99%. So as long as we're working with that, we also need to know what the degrees of freedom is. Degrees of freedom is n minus 1. What I would suggest that you do on your formula sheet, if you don't already have that, take the formula sheet out and write critical values chi-square with the r, the chi-square with the L. 1 minus c divided by 2, 1 plus c divided by 2, and then the degrees of freedom is n minus 1. All right, here's an example right here, and we're going to do this example. Is find the critical values for the 95% confidence interval. So the left and right tail, we have 0.025, which is like 2.5%, and 97.5, which is like 97.5%. Now what I need you to do is get your distribution table out. Ms. Jack, hit pause for a minute if you want. Now that you have your distribution table out, please go to table 6. This is going to be where we actually use the distribution table. You might say, well, you show us the table and then you always show us the calculator way. With the chi-square, you are not able to find it with a TI-83 or TI-84. I called Texas Instrument last year. They're very good about support. They said there was no function on the calculator that allowed to find the chi-square distribution. So you must know how to use your chart on this. If you do not have your chart, I would suggest that you look on with somebody next to you. Now the chi-square distribution, if I have the chart here, right? Let's take a look at that first example that we were talking about. It said degrees of freedom is 17. Chi-square to the r. So we're looking at 0.025. Chi-square L, 0.975. If you're wondering where we're getting those numbers from, if you're looking at your sheet right here, it says n is 18, so degrees of freedom is 17. Chi-square r and the chi-square L, 1 minus the confidence interval divided by 2, 1 plus the confidence interval divided by 2. So the critical values on this sheet, you can write chi-square r or chi-square L, doesn't matter which one. Keep in mind the right one is always going to be bigger than the left one. So if I go to the chart, degrees of freedom we know is 17. So you go down to 17, I'm going to go across. First I'm going to find 0.975. I go down, and that is 7.564. Then I go over to 0.025 to find the right tail, which is always going to be a bigger number, and it's 30.11. Now I'm going to give you a minute to do a second example. Let's just say n is 12. So you have to solve for the degrees of freedom. And the confidence interval is 0.90. Take a minute, find the two numbers. In this case, if it's 90%, you're using 0.95. and 0.05. Because if you go 1 minus 0.9 divided by 2 is 0.05. And if you do 1 plus 0.9 divided by 2, you get 0.95. So there's the 0.95. You're going down that column. And then you're going down the column. I don't know why it's doing this. 0.05. There. So if n is 12, degrees of freedom is 11. So then I go straight across. Your value here should be 4.575 and 19.675, I think. So that's the second example. If you want to write those down in your notes, you can. The chi-square r is 19. Oh, there, did it again. All right, I'm done trying to work with this marker on this. So just write down 19.675 for the chi-square r, and the chi-square l is 4.575. Write down that one for the left one. There, we're going back to the notes, the critical value, for example 1. Now that's getting critical values. And make sure you use the table 6 distribution, the chi-square distribution. Now the confidence intervals are shown here. And then there's the guidelines, just like you had in section 6.1, 6.2, 6.3, the guidelines. I'm going to try to speed this up a little quick. If you need to see this video, I will post this video online. Also, Ms. Jett can also rewind any part that you want to see again. So guidelines. And when we do an example, we're just going to follow right along with the guidelines. The first thing you're going to have to do is degrees of freedom is n minus 1. If you are doing this problem, or these problems from this section, and say, I don't know what the mean is. Well, you don't need to know what the mean is, because we're finding the confidence interval for the variance and standard deviation. Second step is s squared, which is variance or the standard deviation squared. If you want to use it, write down the formula right here in your formula sheet, you can, but do you really need it? No. I'll tell you why. You're either going to be given it, or you can use your calculator to find it. Just like we did in 6.2 with finding values, you put it in your calculator, one variable stat, and that gives you the sample standard deviation. 3. If you want to write down how to solve this again, you can, but I'm just going to write down the values. You have a chi-square L, which is the left tail, chi-square r, which is the right tail. Now the last step, I'm going to put as 2 steps, but sometimes it's only 1, whether you're just doing variance or variance and standard deviation. So for variance, if you would rather write this as an interval, you could as well. By putting the point estimate in the middle, it's like saying the interval. Here's the left end point, here's the right end point. For the variance, you take n minus 1. What is n minus 1? N minus 1 is the sample size minus 1, which is also the degrees of freedom, times the variance or the standard deviation squared. Here's a key on this. If you're given the standard deviation, you have to square the number. If you're given the variance, you just write down whatever that is. Divided by the chi-square r. Some of you are confused. Why is the r going on the left side, the L on the right side? Even after my explanation, if you're still confused, just write this down and just plug in the number with the formula. The reason why the right tail goes on the left side is that number is always going to be bigger. And that would make this whole number on the left side always smaller. So on the right side, I take n minus 1 s squared chi-square L, because that's the smaller of the chi-squares. If you just want to think of the two chi-squares, the bigger number goes on the left, the smaller number goes on the right to produce the final number. Standard deviation. All it is the square root of whatever the variance is. If you want to write this all out again, you can. Struggling here. But you don't have to. You can just put square root if you want. So square root the whole thing. I'm going to slide this up. Here is an example where we're going through the whole problem. It says you randomly select and weigh 30 samples of allergy medicine. The sample standard deviation is 1.2 milligrams. Assuming that the weights are normally distributed, construct a 99% confidence interval for the population variance and standard deviation. So you have to find both the interval for the variance and the standard deviation. I'll give you a couple minutes to try this on your own. Ms. Jack, if you could pause the video, that would be great. All right, now coming back to it, I'm sure there's a few of you that went all the way through and did it correctly, got the right numbers. Some of you had an idea, but not totally, and others just sat there and talked. Now, no matter where you're at with this, please follow along as I go through this. It says you randomly select and weigh 30 samples. You know your n is 30. It says the sample standard deviation is 1.2. So if I square that, I get 1.44. Confidence interval for 0.99 is 0.99, that's 99%. Now first step, if I go by the steps, degrees of freedom is 29. The sample standard deviation is 1.44. Sorry about the screen, just keep moving around there. Now I'm going to go back to this chart. And the thing that I want you to do with this chart is, let's go down. I'm going to go to 29. Okay, I find 29 on the chart. There we go. Now you should take 1 minus 0.99 divided by 2, 1 plus 0.99 divided by 2. So you should get 0.995. So we get 13.121. And 0.005 is 50.993. Now that I have my critical values from my chart, let's go back to this problem. Degrees of freedom, 29. S squared is 1.44. Divided by 50 point, forgot already what it was, 50.993. Now this is finding the variance. And then I take 29 times 1.44. The top doesn't change. Over then 13.121. Now to finish this off with my calculator, take 29 times 1.44, divide that by 50, .835. And the standard deviation, or the variance, okay, the right endpoint, you take 29 times 1.44, divide by 13 point. I'm sorry, and this one is, it's not .835. I thought I was a little bit off on that. If I take 41.76 divided by make it .82 for this one. Second one, take 41.76 divided by 13.121, 3.18. All you have to do to get the standard deviation is square root both of them. First one, if you round it, I get .91. The second one, 1.78. So you have two sets of answers. Your first answer here is the variance. The second answer is the standard deviation. Your assignment from 6.4. And if you need some extra time tomorrow to work on it, we can, as long as you're working quietly in class the rest of the hour. Do number 3 through 13 odd. Your assignment is 3 through 13 odd. And if you have any further questions with this, I'll be around later today or tomorrow morning.